Assalamualaikum and hi! Welcome to Forensic Fiesta Online Expo. So today, I'm going to tell you about CSI. So, what is CSI? CSI is the short form for Crime Scene Investigation. It is the use of physical evidence at the crime scene and the use of deductive and inductive reasoning to gain knowledge of the events surrounding the crime. Crime scene investigation involves processing and collection of physical evidence such as fingerprints, footwear impressions, hair, fibers, material for DNA analysis. But for today, we are going to focus only on fingerprints. Before we explore more about fingerprints, I want to show you a famous case that includes fingerprinting. Do you know this man? He is Thomas Jennings, an African-American man who became the first criminal trial that used fingerprints as evidence in the United States. On September 19, 1910, at 2 o'clock in the morning, Thomas Jennings, in an attempt of robbery, he shot a guy whose name was Clarence Hiller with a revolver at Hiller House. In order to flee himself from that murder scene, he accidentally used a freshly painted railing to hoist himself through a window. But unwittingly, he left behind his own fingerprint on that red railing. He was stopped a half mile away from murder scene wearing a torn and bloodied coat and carrying a revolver. Police photographed and cut off the railing itself, claiming it would prove the identity of the burglar. In the eyes of the court, they were right. Hiller's murder have led to the first conviction using fingerprints evidence in a criminal trial in the United States.
Hi guys, welcome to Forensic Expo. My name is Satish. I am a second year student and I am from Forensic Science. So now I'm going to teach you how to detect or how to find out invisible fingerprints which we can't see by our naked eyes. We're going to use dusting technique to find out the fingerprints. Normally, forensic officers will use black powder, white powder, magnetic powder, but instead of that, we're going to use carbon powder which is from pencils. First of all, we need to prepare all the materials which we need to proceed. Materials are glass or any smooth metal surface, scissor, tissue or any old clothes, A4 paper, clear tape, grinded carbon powder, and also a brush with soft bristles. Step 1. What you guys need to do is wipe your glass with tissue or old clothes to make sure it is clear and also clean. Next step, choose one finger from one of your hand. It doesn't matter which finger you can choose, but I suggest you to choose thumb because it have larger surface area compared to other fingers so that it can give clear fingerprint pattern. Once you choose it, press gently on the smooth glass. While you are pressing, do not move your finger. Another important thing, if your hand is so dry, it won't give a clear fingerprint pattern. So, if your hand is so dry, don't worry. I have a solution. Rub your finger on the nose to obtain sebaceous secretion so the oil will transfer onto the glass and give a clear fingerprint pattern. That's all. Dip your brush into the carbon powder and tips of your brush should be covered with carbon powders, and then tap your brush to remove any excess carbon powder. Next, sweep your brush carefully where you put your fingerprint, and note that do not apply too much of pressure because it can wipe your fingerprint away. Use a piece of clear tape and carefully press the tape down onto the surface on the top of the fingerprint. Make sure there is no hair trap in between the tape and the glass. So what you need to do is press the hair bubbles out gently when placing the tape onto the glass. Then peel the tape off slowly and transfer the fingerprint onto the piece of paper. That's all. There is your visible fingerprint pattern. Result from the fingerprint testing, and my fingerprint shows the loop pattern. And do you guys know what is the loop means? It is the one of the pattern in the fingerprint. There is the 3 patterns, and you guys also will find out which one is yours in a while. And I hope this video will be very useful to you all, and hope you guys will find the clear fingerprint pattern of yours. If you guys also get the loop pattern, you guys all my category. And thank you to watch this video, and goodbye, see you again.
Hi everyone, since all of you have your fingerprints ready, I am now going to help you all identify your fingerprints by explaining the types of fingerprint patterns. According to the Henry system, there are 3 major fingerprint patterns, which are arches, loops, and holes. Let us start with arches. How can we identify an arch? An arch has ridges that enter from one side of the finger and flow out the other side with a slight rise in the center. Arches are further divided into 2 sub-patterns, which are the plain arch and a tented arch. The major difference between these 2 patterns is that the tented arch has a delta, while the plain arch doesn't. What is a delta, you may ask? A delta is where the flow of ridges resembles a triangle and the ridges won't intersect with each other. The next pattern I'm going to explain about is the loop. You can identify a loop when you see one or more ridges that enter from one side of the finger, forms a curve, and exits from the same side it entered. Loops are also further divided into 2 sub-patterns, which are the ulna and the radial loop. Both loops have one delta and a core. The difference between the ulna and radial loops is that the ulna's curve starts from the little finger side, while the radial's curve starts from the thumb side. The last pattern is a hole. For this pattern, The ridges enter from both sides of the finger and flow in a circular way. Unlike arches and loops, holes are divided into 4 sub-patterns. The first is the central pocket loop. A central pocket loop consists of one returning ridge and one delta. The second is a double loop. A double loop consists of 2 separate loop formations in the middle and also have 2 deltas. The third is a plain hole. A plain hole has a circular spiral pattern in the middle, again with 2 deltas. Last but not least is the accidental hole. An accidental hole is stated to have a combination of different types of patterns with 2 or more deltas present in the pattern. Everyone will wonder why fingerprints are that important. Since each fingerprint pattern is unique to a specific person, it can therefore be a reliable way to identify suspects in cases like theft, homicide, and murder. It also provides biometric security, for example, to control access against secure areas and systems such as bank accounts. Lastly, it is also useful to conduct background checks, which are usually done by the government for several applications. That is all from me. Thank you.
Hi guys, my name is Taki. I'm first year student from Forensic Science program. I hope you guys enjoyed the expo and the activity that you guys have done. And the most important thing is, I hope you guys learned something from this expo. Right now, in our segment, you guys are going to learn one of the subspecialty in forensic science, which is ballistic. I know most of you doesn't know what is ballistic, and maybe some of you have never heard the words before. So, let me explain what is ballistic. Ballistic is actually a study of firearm and ammunition. We forensic science students learn about how to identify the firearm, the ammunition, how does it work, how does it function, and the most important thing is we learn about what evidence that this thing left behind at the crime scene, because it can help a lot in the investigation. So before we go further details, let us find out the basic thing in ballistic, which is firearm and ammunition. So what is firearm? Firearm is actually a weapon that can launch bullets or projectile. It has 3 basic parts in it, which is action, stock, and barrel. Action is actually a moving part that can load or fire the ammunition and eject the cartridge case. And then the second part, which is stock, is a part where held by the shooters, and the last part, which is barrel, is a metal tube that projectile or bullet travel through. These 3 parts is only a basic part in firearm, and actually there is many more parts in firearm, depends on the types of firearm and the model. There is actually 3 types of firearm, which is handgun, shotgun, and rifle. Different types of firearm have different use. There's many more things that you guys can learn about firearm, but I think this is the only thing that I can share to you guys right now. So let's move on to the next part, which is ammunition. So what is ammunition? Before I explain, I want you guys to imagine a bullet before it fired from the gun. The things that you guys imagine right now is actually an ammunition. Yes, it's actually an ammunition. A bullet, on the other hand, is merely parts or components of ammunition. Ammunition is actually one or more cartridges case that consisting of bullets, propellant, and primer. In ammunition, at the front part, which is the tips of ammunition, there is actually a bullet, and then it's attached with the cartridge case, and inside the cartridge case there is a propellant, or most of you guys know as gunpowder. And then at the back end of the cartridges, back end of the cartridge case, there is a primer. I hope you guys can see and can picture the image of ammunition. So how ammunition works and how can bullets separate from the ammunition. So let me explain. When you pull the trigger of the gun, the spring mechanism will hammer the metal firing pin at the back end of the cartridge, and it will ignite the small explosive in the primer. So when there is small explosive in the primer, it can ignite the propellant because, as you guys know, propellant is gunpowder and it can burn easily. So when propellant's chemical burns, it can generate lots of gases very quickly, and it causes the pressure inside the ammunition from low to high very fast, and that is the reason why ammunition, the bullets can be separate from the ammunition, and it travel through very fast, and it can kill people. That's all from me. This is actually only a basic thing in ballistic. I hope you guys understand, because after this, my friend Danny going to explain more further details about ballistic. I hope you guys enjoy it and have a nice day. Bye.
Hi everyone, Assalamualaikum. My name is Dania Akilah binti Masim Syaizan. So what I'm going to talk about in my part is 3 things that I would like to share on what are the things to note in a ballistic crime scene. First is definitely the bullet and the bullet's casing. If you go to a crime scene and you don't see any bullet or any of its bullet casing, how can you determine or deduce whether that scene is a ballistic crime scene? Because you don't have any proof, you don't have any of the ballistic items. So that is the important thing to note. You have to look for the bullet and the bullet casing, because if you don't have those, you can't bring or convict the suspect or perpetrator in the court, because you don't have any proof that it's a ballistic crime scene. Second is gunshot residue. Gunshot residue is a component of ammunition. It is primarily consisted of burned and unburned particles when a bullet is fired from a firearm. This gunshot residue may be found on the skin or the clothing of the shooter, or can be found on victims. This gunshot residue can also be presented on target materials at the crime scene, and also people who are at close proximity with the crime scene may also be presented by the gunshot residue. Therefore, any interpretations of who the shooter may be must be approached with caution, because the gunshot residue can be anywhere. And the final important thing to note in a ballistic crime scene is the bullet trajectory. Bullet trajectory actually gives you a picture as to where or from what height is the shot released. Is it shot from lower levels? Is it from higher grounds? Or is it a long distance gunner? Or it could also be a short range gunner. So that gives some hint into solving the case. Also, bullet trajectory may also deduce the height of the perpetrator on how tall or short he or she may be. So those are the 3 things. I'll repeat again. The first one is bullet and the bullet's casing. The second one is gunshot residue, and the final one is bullet trajectory. So now, focusing more on the bullets, because that is what our home lab kit will be about. When a firing process occurs, the bullet passes down through the barrel. In the barrel, there are lands and grooves that guides the bullet to spin, accelerating its motion as well as increasing the shot's accuracy. These lands and grooves leaves striation, markings or impression on the surface of the bullet, which what forensic ballistic experts refer to as bullet striation. When a bullet is discovered at a crime scene, the unique markings on its surface is used as evidence to link the bullet to a specific firearm. Later on, or maybe during the same time, when the firearm is discovered, forensic ballistic experts will conduct test fire. The bullet striation that was retrieved from the test fire is compared to with the bullet striation that was found at the crime scene. So if they have the same striation marks, then it can be suggested that the bullet found at the crime scene did indeed came from that particular firearm. So I think that's it on the theories of ballistics. Let's now dig into some ballistic cases. A real life example on how forensics ballistic experts help solve a case back in 1990 in Illinois, USA. But before I share this story, we all have to understand that in USA, it is actually legal to have weapons of a certain grade allowed by the government, of course, or the military. So what happened in 1993 was a man allegedly murdered his girlfriend in their car, and he was sentenced to prison after trials in court where they had witnesses giving out their testimonies approving on the conviction. However, in 2019, that same man who was still in the prison, he asked for a favor from lawmakers to retest his ballistic evidence on the case, as during that time there was also a rising technology in ballistic called the IBIS, Integrated Ballistic Identification System, which offers a high resolution and a multi-dimensional image to compare the striations on. So this retest allowed forensic ballistic experts to take possession of that man's gun, and they conducted test fire on that gun to compare the bullet striation during the test fire and compared with the bullet back in 1993 when it was submitted as an evidence. So it was proved later that the two bullets was not of a match. So the bullet at the crime scene did not come from that man's weapon, that man's gun. So he had to actually spend more than 20 years in prison for a crime he did not commit. So here it is very crystal clear that ballistics do help solving crime cases, and of course the technology that is growing more than ever also plays a main role, huge role into solving crime cases. So I think that's all from me.
Guys, my name is Jamie and I will be demonstrating you how to use your home lab kit. So without further ado, then let's get started. In your home lab kit, you can see there is 10 pictures of surface of the bullet. 5 pictures is the reference bullet, while the another 5 picture is the suspected bullet that we assume was used by the suspect at the crime scene. So your job is to find the match of each pair. Sounds easy, but actually it's not. The first thing you need to do is to find the length and the groove of the bullet, and lastly you need to match each of the striation of that bullet so you can assume that that is the bullet that comes from the same weaponry that we used to shot the reference bullet at the lab. Okay, so before we can start our pair matching up with the reference bullet and the suspected bullet, you need to find the class characteristic and also the individual class characteristic. The class characteristic of the bullet has many differences, such as the diameter of line and groove, the numbers of line and groove, and also the degree of twist, and so much more. While the individual class characteristic, we can took the striation of the bullet, right? So after I already informed you about those individual and class characteristics, let's apply that, shall we? So first thing first, I will take one example from the reference bullet. I will pick this one. Okay, this is my picture as an example for reference bullet. The first thing first, you need to find the class characteristics. Here is the length and groove. So I believe you already been informed about the length and groove of the bullet. So, but how do you want to apply that and use it to observe the length and groove of the bullet? in this reference picture. So let me show you. This is the groove, and this is also the groove. Meanwhile, the between of those grooves are lengths, and the length of the bullet. So you already obtain one of the class characteristic of the bullet, that is length and groove. So by using that information, you can narrow down and eliminate some possibilities that you can avoid, so to increase your accuracy to find the correct pair. Alright, so after that, try to find the identical length and groove by identifying the diameter of the length and groove and the number of length and groove and so on. So after I analyze and observe, I believe this picture has the exact same length and groove, as you can see here. Okay, you can see here. Alright. So we can determine that this reference bullet is also identical to this suspected bullet. But do not assume that this is the bullet that we are looking for. You need to also consider about the individual characteristics, that is striation. By doing that, we need to use the consecutive matching striation theory, or CMS theory for short. What is CMS theory? CMS theory is where you consider, or you take 2 or 3 groups, or 2 or 3 lines of striae that has the same exact relative position on both of those reference bullet and also crime scene bullet. Alright, so by doing that, you need to find out which striae that you want to pick as a point striae. I will pick this one, right? If you find more striation, then it's better. Okay, and then try to match it up, right? Try to match it up those with this here. So it has the same number of striation, it has the same relative position. So we can conclude that this is the exact same bullet that comes from the same weapon that we use by the lab as a reference bullet. So after I explain all this, now I want you to try the rest of the picture. You try. If you manage to find and match it, every single bullet that you found in this picture, you are one step ahead to become a forensic investigator of firearms and ballistic. But if you're not, don't worry, you have time to improve yourself and learn more about firearms and ballistic in forensic science. I hope you enjoy your time in our Fiesta, and see you next time. Peace out.
Guys, I'm Lisa and welcome to Forensic Fiesta Online Expo. Today I am super excited to talk to you about forensic DNA. So I'm going to start by introducing to you to what is DNA. So basically DNA is the hereditary material that is stored in cells nucleus in humans' body. Fun fact, there are 99.9% of humans' DNA sequences are all the same in every person's body. But in forensic science, we are looking at the 0.01% difference in every person's DNA except for identical twins. DNA profiling is a forensic technique in criminal investigations where the investigator will compare the criminal's DNA profiles to the DNA on the evidence encountered in the crime scene. The aim of this process is to assess the likelihood of the suspect's involvement in the crime scene. DNA analysis has been proved to be a useful tool for crime scene investigation, which helps in criminal justice system. So at the crime scene, the investigator will collect the items that may have these DNA materials, which may have been touched or worn by a person that involved in a crime. Eventually, this explains the locus exchange principle, which states that whenever two objects come in contact, the transfer of material will occur. In this video, you will also be learning on how to collect DNA sample. So have fun and stay tuned, guys.
Good morning. My name is Shalini, daughter of Parthiban. I am going to show you all how to collect DNA sample from a suspect or victim from a crime scene using buccal swab collection method. This is sterile collection swab and this is FDA microcard. We are going to collect buccal swab sample from the suspect and going to store using this microcard. This microcard has many advantages because it can store DNA sample up to 16 years. So after several years, when the case has been come to court again and there is any problem, we can still have the storage of the sample that we can further do analysis in future. Cheek cells will be collected using the sterile collection swab. Peel it off, take out the cotton swab. Rub onto the buccal to collect the cheek cells on the cotton swab for about few seconds. After that, transfer the collected DNA sample onto this microcard. This microcard will change color from yellow to white, indicated that successful DNA sample has been collected onto this card. After that, this microcard has been completely dried. We will be using Harris micropunch to transfer this DNA sample into microcentrifuge tube for DNA extraction method. From here we can see this is the yellow medium and this is the white color medium. So we should make sure that we collect the DNA, the white region only. This Harris micropunch has a sharp tip here that can actually make the microcard hole to collect the DNA. Push it. Okay, here it already make a hole and the DNA sample has been collected at the tip of this Harris micropunch. And then transfer this to here into the microcentrifuge tube. Here may contain impurities which might distract the DNA band in the result. Therefore, we should purify it first before the PCR reaction. Here we are going to purify it using the FDA purification reagent and TAE buffer. Wash the DNA sample we collected with FDA purification reagent 3 times using this pipette method. Repeat this with FDA purification 3 times and TAE buffer 2 times. The next step after DNA purification is PCR reaction. For PCR reaction, we need to add DNA polymerase, DNTP, magnesium chloride, tag buffer and primers forward and reverse for the reaction to take place. This entire mixing of reaction for PCR process should be carried out in ice. After the mixing of DNTP, DNA polymerase and all other PCR components, we should transfer this DNA sample from the microcentrifuge tube to PCR tube to be inserted in the thermocycler. In PCR reaction, we will use thermocycler. The main purpose of PCR is to amplify the DNA fragments into million copies. This is the DNA that we prepared just now. We place it inside this thermocycler. This thermocycler got 96 valves, so it can amplify 96 DNA samples in a single time. And then on the screen we can set our own protocol and then we can run the sample. Here you can set the volume that needed 25 microliter or 50 microliter. This instrument is called as UV transilluminator. The function of this instrument is to visualize the DNA band integrated in the gel under the UV ray.
There are 5 characters involved in case 1, rape and murder. First is Ain, the student. Second is Ahmad, the Grab driver. Third, Ali, the owner of the grocery store. Fourth, Samad, the employee at Ali's grocery store. And fifth is unknown man. The story begins when a student wanted to go home after a study session at a tuition center at 10 pm. As usual, she would go home with Grab. Once the Grab she ordered arrived, she immediately got in. On the way home, in the car, the Grab driver, Ahmad, started a conversation. Ahmad, who do you live with? And Ain, I live with my family. And Ahmad again, oh, I see. Is your parents already home? Ain, usually they will be home by now because it's already past the office hours, right? And Ahmad, that's right. Ain. Ain, who was friendly, answered all his questions. After 10 minutes in the car, Ain became skeptical because she should have arrived at a place, but Ahmad took a different route than she usually takes. Ain asked Ahmad, Ain, Uncle, where are we going? Ahmad, I want to stop by the grocery store to buy cigarette. Once arrived, Ahmad went to buy cigarettes and left Ain alone in the car. When Ahmad arrived at his car, he saw that Ain was not there. Ahmad went round and looked for her. Unfortunately, the grocery store is surrounded by forest. Ahmad was confused to find Ain, but he still did not find her. He asked the grocery owner if he saw a female student or not. Ali looked for his worker to ask the same thing. Ali, Samad? Oh, Samad. Samad? Huh? He's not here? He suspected his employee because his employee is an ex-offender. Suddenly, Ahmad remembered that he stumbled with a man wearing a black sweater, ripped pants, a black hat, and engrossed in scratching his body. He looked at the man suspiciously by his appearance. After Ain did not show up for a long time, Ahmad immediately called the police. Police arrived and started to investigate. Ahmad and Ali were questioned by the police. At that moment, Ali's employee suddenly appeared while wiping his clothes. He did not seem to know anything that happened, and was also questioned by the police. After almost 3 hours of searching, the police team found Ain naked and covered in blood in the forest nearby. Ain has been raped and murdered. Police also managed to arrest the suspect who was hiding at the crime scene. The evidence found in connection with DNA. First is victim's blood on the stone. Second, the semen found on victim's body and the suspect's semen. Third, the hair of victim and the suspects.
My name is Hong Liang, and welcome to the Forensic Entomology subspecialty. So I bet some of y'all don't really know what in the world is entomology, right? Okay, don't worry. We are here to explain in this video. So forensic entomology is the study of insects and arthropods, such as flies or spiders, in a criminal investigation. Right from the early stages, insects are attracted to the decomposing body and may lay eggs in it. Sounds kind of girly, right? I know. So I think we can all relate to this while we see many flies hovering around those fresh meat at pasar, right? So these insects will lay eggs at decomposing bodies, And by studying these larvae, forensic entomologists can estimate the cause of death and also the time of death, or another fancy way of calling it, minimum post-mortem interval, MPMI, of the body. So there are 5 stages during decomposition of body, which are fresh, bloated, active decay, post-decay, and lastly, dry stage. Among these stages, fresh and bloated stages play a big role in estimating the time of death, as insects are most attracted at these early stages. Okay, now enough of me talking. I'll pass to our Miss Shannon to explain more on these examples of forensic insects.
Thank you, Liang. That was a really good introduction on forensic entomology. So, what are the examples of forensic insect, you wonder? In general, flies. Example, blowflies, flash flies are the first to visit a corpse to lay their eggs. Once eggs hatch, the fly larvae begin feeding on tissues. Besides that, beetles. Example, carrion beetles, hem beetles, rove beetles are also commonly associated with decomposition and can be used in the estimation of the PMI. Some insects can also interfere with the estimation of this PMI. For instance, ants, or also its fancy name, Formicidae. So these ants present at the corpse may eat fly eggs and larvae, hence slowing the decomposition rate of the corpse. Now, Liang will tell you what are the key differences between species of flies and how to differentiate them.
All right, thank you, Shannon. So insects that are mostly found in forensic investigations are true flies or Diptera. So under the category of true flies, we have 3 main families, which are Calliphoridae, blowflies, Sacrophagidae, flash flies, and lastly Musidae, houseflies, and their relatives. I'm sure you may have seen some of these species of flies before. Now let me show you some pictures of each flies. So this is Calliphoridae, the blowflies. It is shiny and with a metallic blue, green, or black color on their body. Looks familiar, right? Now next, we have Sacrophagidae, the flash flies. As we can see, it is quite different from the blowflies before. It has black and gray stripes instead of the shiny one. And lastly, we have our Musidae, houseflies, and their relatives. It is quite same with flash flies, except they are dull and smaller than Sarcophagidae. Interesting, right? So blowflies and flash flies may arrive within minutes following the death of a body, whereas houseflies only arrive at bloated stages of decomposition. Okay, next, I'll pass the video back to Shannon again.
Once again, thank you, Liang. So, what are the importance of forensic entomology, you ask? Forensic entomology is important in determining the elapsed time since death. Insect evidence may also show that the body has been moved to a second site after the death. For instance, some insects on the body may be native to the first habitat and not the second. This will show that not only was the body moved, but it will also give an indication of the type of area where the murder actually took place. And it is also important to tell that if the body has been disturbed by any animals or by the killer returning to the crime of the scene. When this happens, it may disturb the insect cycle, and the entomologists may be able to determine not only the date of death, but also the date of the return of the killer. However, the primary importance of forensic entomology today is to determine elapsed time since death. Now, Bhavanish will briefly explain to you on how insect samples are collected and preserved from crime scenes.
Thanks, Shannon. So by now, I'm sure all of you have a rough idea of what forensic entomology is and how important it can be in solving crimes. So as mentioned before, specimens of forensic entomology play an important role in solving cases, especially when there's a carcass involved. So obviously you would want to collect the specimens from the carcass so that further investigations can be done. So essentially, there are three main details that forensic entomologists need to pay attention to when they are collecting samples and preserving them at the crime scene. So these include collecting the live and preserved specimens, recording the conditions of the scene, like its surrounding temperature and weather conditions, and finally, transporting the specimens to the lab while maintaining the chain of custody. So first, let's talk about specimen collection. So obviously, the first thing you need to do before entering the crime scene is to make sure you wear the appropriate attire. So this is done to avoid contamination of the scene. Next, you should introduce yourself to the investigating officer or the person in charge of the crime scene. Then you need to establish the area for collection of specimens. So always be sure to bring along your forensic entomology kit. This kit should have all the necessary equipment such as forceps, jars, vials, hand net, and other important tools for you to carry out specimen collection or preservation. You will also need to collect 3 or 4 soil samples from under the ground where the carcass is. To preserve the soil samples, place it in the refrigerator, but make sure not to freeze them. The same goes for the collected specimens. They should be placed in a cooler or in the fridge. Remember to never freeze them. So it is advisable to collect about 2 dozen big maggots and fly pupae, but make sure to separate them. Fly pupae look like long red to dark brown seeds, so be sure not to miss them when you're collecting samples. I will attach an image here so you can have a quick look at how it looks like. And when you're collecting maggots, make sure you separate them based on their characteristics. So for example, if you're collecting hairy and smooth maggots, make sure they are placed in 2 separate jars. And if you're preserving the maggots, place them in 70 to 90% ethyl alcohol. So once you're done with specimen collection, you need to record the condition or ecological features of the scene. So things that you should be recording include condition of the carcass, temperatures of the body, larval masses, and temperature of the surrounding. You also need to get information regarding the weather prior to the discovery of the body and during the present time. Finally, after recording the data and collecting the samples, you need to label all your jars and other packages that contain your samples or data. You need to write down your name, the person receiving it, the date and time of sample collection, and other related information. Then at last, you must seal each sample securely to guarantee the chain of custody. I know that was a bit technical, but I hope you guys understand and familiarize with the important steps that need to be done when collecting and preserving samples at the crime scene. So next comes the fun part. We want you to rear your own live samples of larvae at home using the items provided in the forensic toolkit. So for this, my teammate and my friend Iza will now show you guys how to rear larvae all by yourself. So I hope you have fun.
Okay, thanks to my friends Shannon, Liang and Baba. So hi, Assalamualaikum, I'm Iza. Now I'm going to share with you guys how to conduct a larva rearing inside your house. Also before that, don't forget to bring along the home lab kit that we already provided to you. And yeah, so let's continue watching.
Okay, for the preparations of the container, we need a piece of paper, a pair of scissors, a pin, piece of tissue paper, and a forceps. First, cut the paper into small pieces. Then, crumple it into a small ball. We're going to make it as a base inside the container. Then, place a piece of tissue paper on top of the crumpled paper. Okay, next. Punch holes in the lid to allow the air flow by using a pin or a needle. After that, cover the mouth of the container with a piece of tissue paper. This tissue paper under the lid is important to provide a dark and damp conditions for the lava. Okay, next, to prepare the baits, as mentioned before by my friend Liang, flies are attracted to the decomposing body. So basically, an adult fly feed and harvest their larvae on decaying material because they can detect the odor produced from the rotten material. So to attract the flies, you can use either raw food or leftover food. This part will be a bit longer for you to wait, so make sure to put the baits at the most possible place to find the fly. Most often they can be found outdoors. Okay, then transfer the eggs into the prepared container and make sure to put along with it enough food for the larva once they already hatch. Now all you have to do is to wait because they will begin to hatch within a day. After 24 hours or after a day, the larvae will hatch out and we usually see them in the first stage while they are still 3 to 9 millimeter long and whitish in color. So basically they will eat their way through the decaying food before pupating and then becoming an adult fly a few days later. So if you guys want to see further how the larvae becoming flies, you can continue the rearing up until 1 week.
Let's look at the life cycle of a fly to get a better understanding. The life cycle of a fly starts with an egg stage, moving on to 3 different larva stages, and going through a pupa stage before emerging as an adult. The first larval stage having the length of 3 to 9 mm long after 24 hours. The second larval stage having the length of 10 mm long after 2 to 3 days. And the third larva stage having the length of 14 to 16 mm long with greatly increases in size after 4 to 5 days. In the third stage, they stop feeding and the larva starts to migrate away from the moisture because they like dry and secure areas away from the wet food source to pupate. Lastly, the adult flies emerge from pupa cases after 6 to 8 days. I hope you guys enjoyed watching this video.
Thank you.